Hello class and welcome. Thank you for watching. We are looking at solving the system of equations by elimination. So on the first page, all we have to do is simply add and something is going to be eliminated. So for problem number 1, we're going to add, let me pick a different color pen. Let's do blue so it stands out. So we're going to add going downwards and a positive and a negative 8 added together cancel each other out. Now 7 and adding a negative 2, that's equal to 5y. 16 plus positive 24, that's equal to 40. And dividing by 5, the value of y ends up equaling to 8. Now to find the value of x, we get the equation. I'm going to use the equation on top. It's 8x plus 7y is equal to 16. And I'm going to substitute in the number 8. Oops, not there. Sorry. In here, I'm going to plug it in for the y. So we have 8x plus 7 times the value of y, which is 8. That's going to equal to 16. So 8x plus 56 is equal to 16. You subtract 56 from both sides, and 8x is going to equal to negative 40. You divide by 8, and x is equal to negative 5. So your solution, let me do it in red. Your solution, our solution, I'm going to write in red. Negative 5 and then 8. That's the point. For number 2, again, adding downwards, negative 6 plus positive 6, that's equal to 0. Negative 9 plus positive 9 plus negative 9, adding downward, that's equal to 0. That's eliminated. And 18 plus negative 18, that's also equal to 0. So here, everything got eliminated. So the solution when this happens is that there is no solution. I'm sorry, there's an infinitely number of solutions. So infinite solutions. For number 3, adding downwards, the x's get eliminated. 5 plus 7, that's equal to 12y. And negative 1 plus negative 23, that's equal to negative 24. You divide by 12, and the value of y is equal to negative 2. Now, to find the x value, again, I usually like picking the top equation. I don't know why, but honestly, it doesn't really make much of a difference. For the y, for this y right here, I'm going to plug in the number 2. So 9x plus 5 times the y value, which again is 2, is going to equal to negative 1. So we are going to multiply these two numbers. So 9x I'm going to bring down. This multiplies to 10 is equal to negative 1. Oh, sorry, that was supposed to be a negative 2. I'm supposed to be inputting a negative 2. So that would give me a negative 10. Let me just fix that real quick. Sorry about that.
Is it you today or there?
Okay, so what we're going to do now is simply add the 10. So 9x is equal to 9. So when we divide by 9, x has to be 1. So our solution in the correct order is 1 and then negative 2. So that's your solution. For number 4, adding downwards doesn't eliminate the x's. We end up with 3x, but it will eliminate the y's. Negative 3 plus a positive 3, that's equal to 0. So that gets eliminated. And that's going to equal to 29 plus negative 17, which is 12. So 3x is equal to 12. We're going to divide by 3, and the value of x is going to be positive 4. Now again, I usually like picking the top one, so I'm going to continue with that. And I'm going to replace this time, I'm replacing the x value with the number 4. So it's 2 times that x value of 4 minus 3y is equal to 29. So 8 minus 3y is equal to 29. Subtracting 8 from both sides. Negative 3y is equal to positive 21. Divide by negative 3, and the value of y is equal to negative 7. So the x value is 4, the y value is negative 7. And there, my young friends, is the solution. Now moving on to number 5. Now number 5 again, like everything else on the front side of this page, if I add downwards, I should be able to eliminate something. So here I am able to eliminate the x's. Negative 2 plus 2 is 0. Positive 3 plus negative 3, that's also equal to 0. However, 19 and 15 doesn't get eliminated, so we end up with 0 is equal to 4. Since 0 does not equal to a positive 4, this is where we end up with no solution. So that's the difference between having infinitely many solutions. Okay, let me try to get both of them. So you see, having infinitely many solutions, okay, and having no solutions at all. So again, there's the big difference. On the infinitely many solutions, everything gets eliminated. On the no solutions, only the x and the y values get eliminated. Not everything gets eliminated. Number 6, if I add downwards, here not everything gets eliminated. Negative x plus positive x, that's equal to 0. That gets eliminated. Negative 8 plus negative 8, that's equal to negative 16y. So the y's didn't get eliminated, and we end up with 16. We divide by negative 16, and the value of y is going to equal to negative 1. So now that the the y value is negative 1, I'm going to use the top equation again, negative 1x minus 8y is equal to 4. I'm going to replace the y value, that number right there, with negative 1. So negative 1x minus 8 times that negative 1 value, is equal to 4. So negative 1x, this right here multiplies, and since I'm just going to subtract the negative 8, I'm going to write it as plus 8. 8 times negative 1, that's equal to negative 8. But since I'm going to subtract, again, that subtraction right here, the one I'm going to highlight, this subtraction minus this negative 8, that makes it into a positive 8. And that's going to equal to 4. So I subtract 8 from both sides, and negative 1x is equal to negative 4. Divide by negative 1, and voila, x is equal to positive 4. So the solution to this one now is 4 and negative 1. Now for number 7, we add, and the x's get eliminated. The y's end up giving me negative 8y. You add two negatives, you keep it negative. And negative 32. So you're going to divide by negative 8. And the value of y is going to equal to positive, I forgot the negative sign right there, positive 4. So the y value is positive 4. Now to figure out the x value, again, using the top equation, negative 7x minus 5 times the y value, which again is 4, is equal to negative 20. So let me write in the negative 4. So that should number right there, that y value should be negative 4. And wait, let me write it all. 7x minus 5y is equal to negative 20. Keep it consistent. All right. So again, what I do first before I start using the inverse operation is that I multiply. So again, I'm multiplying a negative with a negative. So this negative 7x is going to just be brought down. But when I multiply these two things together, that's going to make it into a positive 20. No, I'm sorry, negative 20. Excuse me, hold on. Let me start over because the value of y is positive 4. So I'm going to plug in a positive 4 in right there. That number right there should be a positive 4. So let me start over. So we have negative 7x minus 5 times a positive 4 is equal to negative 20. Almost made a mistake there. So positive 4. All right, so now negative 7x multiplying these two gives me negative 20. So when I add 20 to both sides, I'm not going to get negative 40. What I should end up with is 0. So when I divide by negative 7, the value of x is 0. 0 divided by anything, even negative, is still going to just be 0. So the solution for number 7 should be that the x value is 0 and the y value is positive 4. And the final one on the front page will eliminate the x's, but not the y's. With the y's, we end up with 11y. And adding these, this gives you negative 55. So dividing by 11, the value of y is going to equal to negative 5. Now, the x value now. So again, top equation, 9x plus 7y is equal to negative 26. I'm going to replace the y value since y is equal to negative 5. That's going to be a negative 5 right there. So 9x plus 7 times the y value is equal to negative 26. So let me write in that negative 5 in there. And when I multiply those two numbers, the 7 and the negative 5, bring down the 9x, this right here is going to give me negative 35. So I'm going to add, I'm going to add 35. And 9x is going to equal to 9. Divide by 9, and x is equal to 1. So 1 and negative 5. Now, since I'm done now with the first page, again, let me again just remind you of the disclaimer here. The idea again is that you actually worked out these problems out yourself first before you came and checked the solutions there, okay? So there's the solutions to the first 8 problems. Again, I hope the explanation has been helpful, really helpful so far. So let's go to the back now, and in the back again, it's going to be a little bit different in the fact that when I add, nothing in fact gets eliminated anymore, okay? If I add what I currently have, 7 plus negative 5 doesn't give me 0, 7 plus 7 doesn't give me 0, so none of the variables get eliminated. So what we do in this situation right here is that we're going to multiply, as you see right here. Notice that these two are the same. If one of these was a negative, a positive 7 plus a negative 7, that would give me 0. So that's exactly what I'm going to do. I'm going to keep the top equation the same. So I'm going to keep this as 7x plus 7y is equal to negative 7. But for the bottom equation, I'm going to change the signs. I'm multiplying everything in the bottom by negative 1. So that's going to change the negative 5x to positive 5x, the positive 7 to negative 7y, and the negative 19 to positive 19. Now, when I add downwards, that's going to now eliminate the y's because they're now opposites of 7, and a negative 7 becomes 0. So adding everything else, 7 plus 5, that's equal to, again, 12x. And negative 7 plus 19, that's equal to positive 12. So dividing by 12, the x value is going to end up being 1. So what I'm going to do now is to figure out the y value. Again, I'm going to pick the top equation. So 7x plus 7y is equal to negative 7. And I am going to replace the x with 1. So 7 times 1 plus 7y is equal to negative 7. 7 times 1 is 7. And then I would start by subtracting 7 to both sides. And 7y is equal to negative 14. A bunch of 7s in that row right there, okay? So I divide by 7. and y is equal to negative 2. Seems like I said the number 7 a lot in that one there. All right, so your x value is going to be 1 and your y value is going to be negative 2. So that's going to be the solution for number 9. Now for number 10, again, the same thing is going to occur. And this is going to be true for all these examples down here. If I add downwards, nothing gets eliminated. 1 plus 1 is 2. Negative 9 plus 1, 9 plus negative 1x, that's equal to 8. So you see nothing gets eliminated. So what I'm going to do, I should be able to fix it because these are the very simple examples that if all I do is multiply one of them by a negative, then that should eliminate something. As you can clearly see, that would eliminate the x's, okay? If I make one of these x's the opposite, a negative, then when I add the positive, it should give me 0. So I'm going to multiply the bottom one by negative 1. So let's see what we end up with, okay? So the top equation is going to stay the same. And the bottom equation, I'm going to end up with negative 1x, positive 1y, and positive 8. So now when I add, let me change the color here. When I add downwards, this is eliminated. A positive and negative 1 cancel each other out. 9 plus 1 is 10y. And 8 plus negative 8, that's equal to 0. That gets eliminated, so that becomes 0. Now here, this is not going to be an example of no solution. That only happens when both the x and the y get eliminated. Here, I have that 10y is equal to 0. So I would continue solving this by dividing. Since I'm multiplying the y with 10, I would divide it by 10, and the value of y would be 0. Okay? So this is not an example of no solution. This is an example where I still have a y value, and the y value is simply the number 0. Now to figure out the x value, using the top equation, I'm just writing it down again. I'm going to replace this x value with the number, I'm sorry, not the x, the y value with the number 0. Okay, sorry, not the x. So I would have 1x plus 9 times 0 is equal to negative 8. Let me do it in black. So 1x plus 9 is equal to negative 8. So you see, I just replaced the y value with 0, and I end up with 1x is equal to negative 8. So this right here ends up being 0, so I could really just basically ignore it. I don't have to worry about subtracting it to the other side or anything like that, because I end up with the term of 0. So I could just skip that term and just write that 1x is equal to negative 8. Well, I'm going to divide by this positive 1. And dividing by positive 1 doesn't change anything. So the value of x is equal to negative 8. So the solution here, okay, let me just write that x is equal to negative 8. So your solution here is that x is negative 8. The y value is 0. So the two lines are going to intersect at that point, okay, at negative 8, 0. Which again does not mean that there's no solution. They just intersect at negative 8, 0, which is located on that point right there. So the lines, again, I'm not going to draw an accurate line, but the idea is that we have two lines. Maybe one of them is going up, the other one is going down, or maybe both of them are going up. They both have positive slopes, which probably technically isn't correct, but we have one positive slope, one with a negative slope, but they're intersecting at that point right there, okay? That's what this means. Again, this is the point of intersection. And that's true about every single one of them, right? All the other ones that we've done, that they all have, these points are all points of intersection. Okay? So for number 11, let's start off by multiplying the bottom one by negative 1, since that's going to be the situation with all of these right here in the back. So we end up with 1x minus 9y is equal to negative 12. Negative 1x, positive 10y is equal to positive 14. And the explanation of why, again, is the same, because nothing gets eliminated. And since, again, a positive one and a positive one doesn't equal to 0, I can make that equal to 0 by making one of them negative. So I'm going to multiply the bottom one by the negative. And now when I add negative and positive 1, or positive 1 plus a negative 1, that's equal to 0. Negative 9 plus 10y, that's equal to positive 1y. And negative 12 plus 14, that's equal to positive 2. I divide by 1, and the value of y is 2. Now to figure out the x, I'm going to go back to the original equations, and I'm going to pick, again, the top one, the one I just highlighted. 1x minus 9y is equal to negative 12. And I'm going to replace the y value with positive 2. So we have 1x minus 9 times the y value of positive 2 is equal to negative 12. We're going to multiply these two numbers first. So 1x minus 18 is equal to negative 12. We're going to add the 18 to both sides, and 1x is equal to positive 6. And dividing again by 1, x is equal to 6. So the coordinate 6, positive 2, not negative 2, positive 2 is the solution. So there you go. Again, now, and again, just to explain this, again, can't explain enough, is that if I add two negative 4s, that doesn't equal to 0. But if one of these was a positive and the other one was a negative, that would definitely give me 0. All right, okay, when I add downwards. So I'm going to do exactly that. I'm going to multiply the bottom equation by negative 1 so that this and this become opposites of each other. So let's write that down. So the top is going to stay the same. Negative 4x plus 10y is equal to negative 13. And we're going to have positive 4x minus 10y is equal to positive 6. I hope you're seeing what I'm seeing. When I add the x's, negative 4 plus a positive 4, that's equal to 0. A positive 10 plus a negative 10, that's also equal to 0. So everything got eliminated over here, so we have 0. So there's just going to be either no solution or infinite many solutions. And when I subtract, negative 13 with a positive 6, which technically is subtracting, that's going to equal to negative 7. Well, here I have no solution. Whenever I have a situation like this, where I end up with a false statement like 0 does not equal to negative 7, this implies that we have a set of parallel lines. That we have our x and y axis, so our x axis, our y axis, and our two lines. Let's see if I could just... Positive slopes. Yeah, positive slopes are two lines that have positive slopes. Okay. Like this. All right. If they're not drawn to scale, they're not accurate. All right. I'm not even bother figuring out what the slope of the y-intercept is. But I do know that the lines are going to be parallel to each other. So this is what we end up having. Because 0 doesn't equal to negative 7, that implies that the graph is going to look like this. It's going to be two lines that are parallel to each other. So that implies that there is no intersection. Okay? And since there is no intersection, that means that there is no solution. So that's what we're going to write as the answer for this system, that there is no solution. Let me write that better. There you go. No solution. Remember, this is how I abbreviate solution, SOLN. A little too lazy to spell out the entire word. So there you go. We only have 4 more to check, okay? So again, thank you for continuing watching and checking your answers. Again, hopefully you have already done this. As usual, my disclaimer is that you've completed this and all you're doing is just checking that you did this correctly. All right, so adding again is not going to work. 5 plus 5 doesn't give me 0, and 1 plus negative 10 doesn't give me 0. But a positive 5 and a negative 5 would give me 0. So let's do that. Let's multiply the bottom equation by negative 1. So we could end up with a negative 5x, a positive 10y, and a negative 25. And again, so you see what I did. I multiplied this by negative 1. That way the 5s could be opposites of each other. So adding downwards, and I need the blue pen, adding downwards, this becomes 0. This is 11y. And this is negative 44. Dividing by 11. The value of y is going to be negative 4. So our x value, using the top equation, using that one, 5x plus 1y is equal to negative 19. I'm going to replace this y value with, again, a negative 4. So 5x plus 1 times negative 4 is equal to negative 19. Well, 1 plus negative 4 is negative 4, and adding a negative is the same thing as simply subtracting it. So I'm going to write this as 5x minus 4 is equal to negative 19. That way I can add 4 to both sides. And 5x is going to equal to negative 15. We're going to divide by 5. And x is equal to negative 3. So here's our solution. Put in the x and y value as a coordinate. There's your answer. Two x minus 3y is equal to 19. Negative 2x minus 1y is equal to positive 1. And I should show my work multiplied by negative 1. So now we end up with 0. Let me get back to blue. 0, this becomes 0. Negative 4y is equal to 20. Divide by negative 4, and y is equal to negative 5. So 2x minus 3y is equal to 19. And again, we're replacing the y value with negative 5. So 2x minus 3 times the negative 5 is equal to 19. This gives me a positive 6. Negative times negative. I subtract 6. This is, what number am I? 14. Oh, I'm sorry, that's not 6. What am I thinking? That's 15. Excuse me, I don't know where I got 6 from. I was multiplying 2 and 3. That's going to be positive 15. So I should be subtracting 15, which is going to be 4. I divide by 2, and x is 2. Sorry about that. I went a little too fast for myself there. So 2 and negative 5. If I was in class, I would just use the excuse. I was just checking that you were paying attention. Okay? But obviously, I messed up there. All right? But there, fixed it. Okay? So the value of x is 2. The value of y is negative 5. For number 15... notice again that the x values are the same, so I can't eliminate unless one of them is a negative. So I'm going to multiply again the bottom one by negative 1. And negative 2x plus 4y is equal to 24. Negative becomes positive. Positive becomes negative. And positive 24 becomes negative 24. All right, so now let me add downwards. And look at this. This eliminates. Negative 2, positive 2 is 0. Positive 4, negative 4 is also 0. So 0. And 24 plus negative 24 is also 0. So everything right here got eliminated. Now, again, what this implies and what this means is if I was going to look at a graph of this, so let me just draw myself a little graph just to explain what's going on here, is that we have this line, okay? So let me get my red highlighter. We have this line right here, okay, that I'm just going to illustrate in red, that positive slope. Looks like we have a positive y-intercept also, okay? It's going to look something like this. So this red line right there. And then we have this other line. Let me pick this color right here. This one right here. This line right there. It's going to be the exact same line as the one that we just, the red one, okay? So they are on top of each other. They're the exact same two lines. So the red one is the same as that purplish one that I just highlighted, okay? They're the same. So what that implies is that since the solution to the system is the point of intersection, the solution is going to be all of these points that are intersecting. They're intersecting in multiple places. And these are not just these are just a few of the infinite number of places that they're intersecting. So if they're the exact same line, that implies then that there's an infinite number of intersections. There's infinite intersections. And if there's infinite intersections, that implies that there has to be infinite number of solutions. Infinite solutions there. So that's exactly what we're going to write for this one right here, that there's an infinite amount of solutions, okay? Now, I know I had the same type of thing happen on the previous, the front side of the page, but I just wanted to make sure that since we're towards the end, that I explained it, okay? That I explained it again in case you weren't too clear about why this is going to be the case every single time, okay? So again, know the difference of when we have a situation that has infinitely many solutions, like we have down here on number 15, and no solutions as what we have up here in number 12, okay? Note to distinguish when we have a set of parallel lines and we have, in fact, actually the exact same equation, the same line, okay? And for number 16, this is going to intersect. So they're not going to be parallel or be the actual same line. So the x's should eliminate if one of them was a negative and the other one was a positive. So I'm going to keep the top one the same. And I'm going to multiply the bottom one by -1. So I could have a negative 1x, a negative 5y, and a positive 12. So up here we have a positive 1. So when I add, this becomes 0. This becomes 4y, and this becomes negative 12. So dividing by 4, the value of y is negative 3. Now for the x value, we have x, 1x plus 9y is equal to negative 24. I'm picking again the top equation. I'm picking this equation right there. And I'm going to replace the y value with negative 3. So 1x plus 9 times negative 3 is equal to negative 24. So I'm going to multiply these two, and we end up with 1x minus 27 is equal to negative 24. I'm going to add 27 to both sides, and 1x is equal to positive 3. Divide by 1, and x is equal to 3. And there's your last one, okay? So for the last one, this should be your solution, all right? Again, thank you for watching. Hopefully this was very helpful. The explanations, again, when we have infinitely no solutions or infinitely many solutions, I'm sorry, or no solutions at all. Again, remember we have tutorials this Thursday and every Thursday, so please make plans to attend, earn yourself some extra credit. Again, thank you for watching and have a good day.